I'm Judy Sandrock, and in this presentation I'm going to take you through some Earth observation applications. The topics to be covered are what is Earth observation, the space to decision chain, as well as 3 African applications. So what is Earth observation? We can see here in this graphic that there's a number of Earth observation satellites that are in orbit, and they're all doing different jobs. This is a graphical representation, so they're definitely not this close, and they're probably at different altitudes and different inclinations. So these satellites are orbiting Earth to collect data about our planet. The sensors capture images and measurements we cannot see from the ground, because when we're on the ground, what we're trying to observe is probably over the horizon. This data helps us to monitor weather, crops, oceans, and a lot more. And this information guides better decisions for communities and governments. So let's have a look at this space to decision chain. The sensor data is captured, so the satellites capture the sensor data from orbit. So here is our Earth observation satellites, and here is our target area we can see here on the ground. And so the data is being captured, and it's being downloaded to a tracking station. It can also be downloaded to a receiving station, and in some cases as well is that data can actually go to a communication satellite, which in turn downloads that data. Once that data is on the ground, it's transmitted from those ground stations to data storage or processing stations, and then that data goes into databases and is analyzed by organizations in order that they can actually provide the insights to all of us on planet. So let's go through 3 African applications. Here we can see the first application we're going to look at is early flood warnings. So there are satellites that scan Africa every 15 minutes to detect rainfall. And this data feeds computer models for 6-hour flood forecasts. So we can see here's a number of examples. We have Namibia and Zimbabwe and Malawi and Madagascar and South Africa. And then there's an Africa-wide analysis that is conducted by the African Union. So authorities alert communities before the floods arrive, and especially in Ethiopia, West Africa, as well as across the continent. Here we can see an example of flood waters. This is in KwaZulu-Natal at eThekwini municipality, and this was before the rainfall. You can see the riverbed, and then after the rainfall, you can see how the river actually broke its bed and the riverbed, and you can see this flooding here. So these before and after photographs are really useful to inform authorities of what measures have to be put in place, as well as in terms of insurance claims and other aspects when we're dealing with floods. So the second application we're looking at is farming and drought planning. So here we have 2 images taken by a multispectral camera. So this is the normal image that we would consider, in terms of visible light. But then what we have is we also have a multispectral image where we're actually having a look at, for example, the infrared range, the ultraviolet range, and we can see here that high frequencies is the darker brown color and the low frequencies is the white. And so what this does is this helps us monitor vegetation health and soil moisture. These forecasts help farmers plan planting as well as harvesting, and the data shows which regions could face a drought stress. So these images combined with that of understanding rainfall and moisture are extremely useful when predicting floods and managing crops. The final application we're going to look at is coastal monitoring. And this is about satellites detecting fishing vessels in coastal waters, and that is used for monitoring illegal fishing, pollution, and shoreline changes. We're able to track ships even when they turn off identification systems, and protect marine reserves and coastal communities. So here we have an image where we can actually see these are signals, these are electromagnetic signals that are coming from boats or ships out in the ocean. And let's actually compare that with the data of those where they've actually have their transponder on. So this is the same image that we had, where we're detecting these signals from space. And then this is when the boats or ships turn their transponders on, and they actually alert the authorities as to where they are. So you can see this is exactly the same location. This is Durban Harbour over here, going up the east coast of Africa. So if we take these two circles, which have exactly the same area, we'll see that there's only 10 vessels who have actually turned their transponders on, and there's 22 vessels in total that have been identified. So in cases like this, what it is that then the Coast Guard is dispatched, and they go and they identify these vessels, and they find out, why do you not have your transponder on? Every single boat that is seaworthy has a transponder, and it's the responsibility of the owner to turn it on. So this is a great example of identifying where people are possibly behaving illegally. Maybe they're dumping, maybe they're fishing illegally, or otherwise maybe they're just trying to skirt the rules and not actually abide by the rules. So thank you very much for watching this presentation, and there's a number of links in the description.